Welcome to the deep dive.
Great to be here.
Today we're jumping into a really interesting set of sources. They're from the Economist's Science and Technology section.
Right, dated August 9th, 2025. Fresh stuff.
Exactly. And our mission basically is to unpack some really cutting-edge topics. Some are a bit perplexing, maybe even, slightly unsettling.
Definitely covers a lot of ground.
Yeah, we're going from like the expansion of the universe all the way down to, scientific integrity, defense tech, even health supplements.
Mm-hmm.
The goal, as always, is to pull out the key insights, give you that shortcut to being really well informed.
And I think what's cool today is seeing the connections, how things on a cosmic scale might, in weird ways, relate to questions about research or even our own health.
Right.
So we'll try to synthesize all that, connect those dots for you. Not just the what, but the why it matters,
Right.
and the big questions it raises.
Okay, so let's start big. Really big, this cosmic puzzle.
The cosmological crisis, as the source puts it.
Yeah, astronomers are apparently in a bit of a spin because they can't agree on how fast the universe is expanding.
The Hubble constant. It sounds technical, but it's fundamental.
It's a huge deal, right. And the tension is, there are two main ways they measure it, and they get different answers, which is, a problem.
A big problem.
So method one is looking outwards, measuring things far away, like those type 1A supernovae.
Right, the standard candles. Edwin Hubble started this, and Adam Rees' Nobel-winning work really refined it with the Hubble telescope.
And that method gives a number around, 73.8 kilometers per second per megaparsec?
Yeah, roughly. A megaparsec being, enormous. Over 3 million light years.
Mind-boggling scale. Okay, so that's one number.
Then there's method two, looking backwards.
Right, back to the afterglow of the Big Bang.
Exactly. The cosmic microwave background, the CMB, using data from the Planck satellite and also that Big Bang balloon project.
The CBB, yeah.
And that data suggests a slower expansion, closer to 67.
Okay, so 73.8 versus 67. That's not a small difference.
It's about 9%, which in cosmology is, it's a crisis.
Yeah. Sounds like it.
Because if both measurements are right, and these are careful measurements, then the standard model, our whole understanding of how the universe works, might be missing something. Or be wrong.
So the sources mention astronomer Dan Skolnick basically saying, look, it's either bad data somewhere or we're missing some fundamental physics.
That's the core dilemma, yeah.
What are the physicists leaning towards? Measurement error or new physics?
Well, the sources touch on potential new physics. Maybe dark energy, the thing speeding up expansion, isn't quite what we thought. Maybe it changes over time or something.
Yeah.
Or there's this other idea, early dark energy. EDE.
Early dark energy.
Yeah, like a hypothetical fifth force
that
gave the universe an extra kick very early on, affecting the CMB, and then, poof, disappeared.
Like a cosmic hiccup.
Sort of. It's a way to try and reconcile the CMB data with the faster expansion we seem to see locally. It adds a layer without totally throwing out dark energy.
Fascinating. And they mentioned the Vera Rubin Observatory coming online soon.
Yes, that's seen as a potential tiebreaker. It's going to generate just a massive amount of data on distant objects.
So maybe that'll finally settle this Hubble tension.
Hopefully. It could confirm one measurement, refute the other, or maybe point to something even stranger.
Wow. Okay, so from the biggest scales, let's zoom right back down to Earth. And this one's, it's concerning. Scientific integrity.
Yes. The rise of fake scientific papers.
It sounds bad. How bad is it?
Well, the sources give some numbers. That PLS-1 investigation found 2% of a batch of papers were problematic, had to be retracted or flagged.
2% doesn't sound huge, but in science.
It's significant. And another study mentioned from 2015 looked back 15 years in some fields and found over 4% of papers retracted.
Okay, that's double an earlier figure they cited, so it's growing.
Seems to be. And a key reason pointed out is these paper mills.
Paper mills, like factories for fake research.
Pretty much. Companies that fabricate papers, text, data, even images, sometimes using AI now.
Seriously? AI-generated papers?
Yeah. And they submit them, trying to get past peer review, which, isn't perfect. It relies on trust.
Wow. So it's not just mistakes, it's deliberate fraud.
Exactly. The sources mention one researcher, Alberto Ruana-Ravina, finding like 40% of retracted papers at his university had no real authors linked to the institution.
No legitimate authors.
Right. And half of those came from just one person or group. It points to organized fraud, not just sloppiness.
So why is this happening? What's driving it?
Well, the suggestion is the pressure to publish. Journals and institutions sometimes value quantity, getting lots of papers out quickly.
Right, the publish or perish culture.
That environment can unfortunately create openings for this kind of thing.
So what does this mean for us, for trust in science?
It means critical thinking is more important than ever. Knowing this happens helps you evaluate information.
So check the source, check the funding.
Definitely. Ask, who paid for this? Is the data available? Those are powerful questions. It's not about losing faith in science overall, but acknowledging the flaws and being a smarter consumer of scientific information. You need that critical filter.
Makes sense. Okay, let's shift gears again from sort of abstract integrity issues to something very tangible, high stakes, tangible.
Hypersonic missiles.
Yeah. The U.S. is apparently racing to develop ways to detect these things, especially from potential adversaries like China and Russia.
It's a major defense challenge.
Why are they so hard to deal with? What's the specific problem?
Speed is one thing over Mach 5 times the speed of sound. But it's also maneuverability.
Ah, so they don't just fly in a predictable arc like older missiles.
Exactly. They can change course, making them incredibly hard for existing satellites or radar to track reliably.
Okay, so what's a new approach?
One really interesting angle mentioned is acoustic detection. Listening for them.
Listening. For a missile.
Yeah. The article highlights a system called Hyper-VAPS. It's a prototype using microphones, some on buoys, developed by Hyper-Kelper with Lockheed Martin.
Trying to pick up the sound signature?
Right. And it's not entirely new, actually.
Huh.
The sources remind us that UK used acoustic arrays back in the 60s to detect bombers. So the principle has history.
Huh. Applying old tech to a new threat.
Exactly. And they're thinking beyond just open oceans, maybe deploying sensors in cities, using existing structures, or integrating with advanced underwater systems like SOSUS.
But surely the background noise is a huge issue. Cities are noisy, the ocean's noisy.
Absolutely. That's the main challenge. You need really sophisticated signal processing, probably a lot of AI, to filter out all the clutter and isolate that specific hypersonic signature.
Like finding a needle in a haystack of sound.
A very loud, very complicated haystack.
Okay. Wow. Quite the range today. Let's bring it even closer to home for our final topic.
Collagen supplements.
Yes. You see these everywhere now. Powders, drinks, pills. What's the actual story here, according to the sources?
Well, first, what is collagen? It's the main protein in your body's structure. Skin, bones, tendons, cartilage, it holds things together.
Right, connective tissue. And the supplements usually come from animal parts.
Typically, yeah. Ground up hides, bones, fish scales, that sort of thing.
Okay, so you eat this stuff. Does it just go straight to your skin, make it look younger? That's the promise.
That's the promise, but it's not quite how your body works. Collagen is a big protein molecule.
Mm-hmm.
When you eat it, your digestive system breaks it down into its basic building blocks, amino acids.
Okay, like taking apart Lego bricks.
Exactly. Then your body uses those amino acids, those bricks, to build whatever proteins it needs most at that moment.
Which might be collagen, or might be something else entirely.
Precisely. There's no guarantee those specific amino acids will be reassembled into collagen, let alone sent to your skin or joints preferentially.
So what does the actual evidence say about the claims? Skin, joints, hair?
For skin, some studies show maybe small improvements, a bit more hydration, maybe elasticity, but generally minor effects.
Minor,
Yeah.
Okay. What about joints? Osteoarthritis.
There, some research suggests a small positive effect, reducing pain, maybe improving function slightly, again, usually not dramatic.
And hair and nails, often part of the marketing pitch.
The sources say there's very little good scientific evidence to back up claims for hair or nail health.
And there's a catch with the studies, right?
Potentially significant one. A lot of the studies showing benefits are funded by the companies that make and sell collagen supplements.
Ah, the industry funding its own research.
Yeah, which doesn't automatically mean the research is bad, but it raises questions about potential bias. It's something you as a consumer should be aware of when you see those claims.
Definitely important context. So the takeaway on collagen seems to be it's not a miracle cure.
Not really. Your body is actually really good at making its own collagen, provided it has the right ingredients.
And those ingredients are?
Basic nutrition, essentially. Enough proteins from your diet, meat, fish, dairy, eggs, beans, lentils, gives you the amino acids like lysine and proline, and vitamin C. That's absolutely crucial for the body to synthesize collagen.
So a balanced diet is probably doing most of the work already.
Often, yes.
That's true.
It highlights how sometimes the fundamental approach, just eating well, is the most effective route.
Right. A good reminder, what a journey today. from, the edge of the universe, literally, down to protein molecules.
It really covered a lot.
Yeah.
It showed how science is always questioning, always evolving, whether it's cosmology or research methods or even health fads.
Yeah, it's that constant questioning. That seems to be the theme.
It really is. It's a testament to the process, even when it reveals uncomfortable truths like fraud or uncertainty, like the Hubble constant.
And maybe the beauty of these deep dives isn't just getting neat answers wrapped up. It's about understanding the questions better, seeing that dynamic process.
Exactly. And maybe that leads to a final thought for you listening. In this age, we're flooded with information, but clear answers can be hard to find. Could it be that the journey itself, the act of questioning, of reevaluating what we think we know, is actually the most valuable knowledge we can have?
The process over the product.
Maybe. And perhaps think about what's one piece of common knowledge or conventional wisdom you might be ready to question after hearing all this.